topics we will discuss in the limitations of chemical equations, so that lot of information we can add. I's here representing the physical state of the reactants and products, representing the reactants physical state as well as products physical state. Then next here, sometimes in the activity 1 we noticed that heat is changed. Third one also heat liberated, right? That heat changes we can represent. In the third reaction, activity number 3, we observed that evaluation of a gas. So gas evolved, gases evolved. The next here, in the activity 2, solid substance remained as undissolved. So we can represent that precipitate formed. And also we can represent that speed of reaction, how fast it can takes place or complete, right? So these are the information you are able to add into the chemical equations. So here, expressing the physical state. So here physical states, namely solid, liquid, gas, right? Or sometimes you may prepare that solid in the liquid form, converting, right? Making a liquid. So here that we can express as here solids by symbol S. Just beside the compound formula, maybe hydrogen, suppose. Beside it, we can represent its a physical state as solid, liquid, or the gas. If it is a solid, we can write S symbol. If it is a liquid, we can write L symbol. Itself, it is a gas, we can write G symbol. So L for liquid, G for gases, S for solids. Directly available in the solid, liquid, gas, or if it is converted or dissolved in the water. So any solid dissolved and made as liquid, making a liquid form. So that we can write as here AQ, aqueous solution, added by water or made a solution using water and a solid. So that we can represent as AQ. So these are the physical states representation. The next here, heat changes. So here two types of heat changes are there. It may be absorbs the heat energy, or maybe it can liberate the heat energy. So releasing and absorbing, releasing, or maybe it can absorb. So if the contents become cool after the change, that we can call it as absorption of heat energy, or the reaction maybe takes place by external heat energy. If they need heat energy, heating the contents, that are called as here absorption of heat energy. Or maybe after the change, that contents become warm, becomes hot, so heat is liberated. So heat liberated we can represent as plus Q here. If heat is absorbed, we can represent as minus Q here in the equation. Plus Q towards product, minus Q towards product. So here plus Q liberation of heat energy, minus Q absorption of heat energy. The next, expressing the gas evolved. So the gases evolved in the reaction. For example, zinc reaction with the hydrochloric acid. Salt formed in the form of liquid, and a gas is liberated. Bubbles in the liquid we observed. That is represented by upward arrow in the equation. If a gas evolved, we can represent that symbolically with upward arrow. Expressing them, suppose if a precipitate is formed, right? Expressing the formation of a precipitate. How we can represent the formation of precipitate here, right? So here, if a solid added into the liquid, suppose sand, where it can observe in a liquid container at the bottom. So it is moving towards down. So that precipitate we can represent by downward arrow. Downward arrow. The next here, after expressing the formation of a precipitate, we have one more expression that is about speed of the reaction, the rate of reaction, how fast it is taking place. So it depends on several conditions like a temperature, pressure, or sometimes you may add some substances into the reactants, but maybe they are not participate in the reaction called as catalyst. The substance which can participate, which can increase the rate of reaction, but itself do not participate in the reaction. No participation, but changes the speed. That we can call it as catalyst. So here that we can represent above the arrow or maybe below the arrow, like a temperature, pressure, or extra reactants added as catalyst, so that we can represent above the arrow. The next here, indicating the concentration, the strength of the liquid, acid may be the solid, strength of the liquid. Suppose if it is concentrated, the strength is more strong, then we can represent as CNOC, concentrated, CNOC, short form. If it is added by water, right, mixing, right, so that combination of acid with water, dilution, so we can write DIL beside that reactant. Concentration of acids or maybe the bases or mentioned as dilute or concentrated. So this we can add information into the equations. So these are the limitations for the chemical equations. So we can overcome that. We know the limitations. So adding this information, we can interpret much information into the chemical equation. So here in the reactions, especially in the heat changes, we notice two changes, maybe loss in the energy or maybe gain of heat energy, right? So liberation, absorption, that based on the heat changes, we have two types of chemical reactions, as exothermic reaction and endothermic reaction. Exothermic, existing, simple code. While you are naming the reaction as exothermic, existing, you can use that first starting two letters, existing. So liberation, coming out, something is giving out. So what is giving out? Heat energy. So in any reaction, if certain amount of heat energy is liberated, releasing by the reactants as product, then that reaction is called as exothermic reaction. A reaction in which heat energy is liberated by the reactants is called exothermic reaction, right? So here simply exothermic reaction in our day-to-day life, heat producing, burning process. For example, in the winter season, we can burn, we can use something, wood or fuel to burn, produce heat energy only. So here carbon is a solid combining with oxygen, it is a gas, and commonly they are giving you after the change carbon dioxide along with heat and light, So here this is a representation of exothermic reaction here. This is what? Exothermic reaction. So like this we can represent. Here I written plus heat. So that instead of writing heat, you can use a symbol here, right? Representing the heat with the symbol Q. So we can write also in this form. C plus O2 mu is less to CO2 plus Q. So this is expression for the exothermic reaction plus Q, right? So here, one more type of reaction is there. Liberation of heat is observed, then absorption of heat. If in any reaction that contains after the change products, right? Observed ice cool, then the reactants. Then we can call that reaction as endothermic reaction. And in a reaction in which heat energy is absorbed by the reaction is endothermic reaction. It can absorb the heat energy that contains maybe becomes cool after the change. So these type of reactions are called here endothermic reaction. For example, nitrogen and oxygen combination will give you nitrogen monoxide, NO, right? Along with that, we can observe the changes in the heat energy is lost that becomes cool, right? Also, we can write this equation as N2 plus O2 mu is less to 2NO minus Q, loss minus, or sometimes we may write that heat liberation, absorption is plus Q towards reactant side, right? Right side moving means transposing, minus Q, left side plus Q. So plus required heat energy representing here. So this is also representation of a endothermic reaction. Is it clear to you, everyone? Or sometimes we may use delta symbol above the arrow without using plus Q or minus Q. So delta symbol is used above the arrow for representing required heat energy. That means external heat energy you are providing, heating. Is it clear to you, everyone? Is it clear to you? Go to quick reaction. So you got an idea about endothermic, exothermic reaction. Endothermic, exothermic reactions, right? So next topic for us is about here simply interpretation, right? Interpreting a balanced chemical equation. So already we added extra information to the balanced chemical equation, right? So here what we can refer, what we can read the information, analysis, data gathering from that equation is here interpreting a balanced chemical equation, the data provided by the equation. So simply what the chemical equation gives information as about the reactants and about the products through their symbols and the formulas. So simply you are able to get such information regarding reactants and the products, regarding the formulas also, regarding their formulas also, right? It also gives information about the molecules, right? Ratios, molar ratios, right? So here you will get the ratio of molecules of reactants as well as products. 1:2 ratio, 2:1 ratio, 1:1 ratio. For example, C plus O2 mu is less to CO2. That is 1:1 ratio. Carbon and oxygen combining in 1:2 ratio. If you take H2 plus O2 mu is less to 2H2, H2O, it is unbalanced chemical equation. Make it balance. Then you will get 2:1 ratio. So understand it by writing the balanced chemical equations, right? So here, simply, if you are expressing the masses of the substances as unified masses, that gives you the relation, right, between the masses. Okay, not only about the masses, you are also able to read that molecular masses, moles, right, using their compositions. Molar masses you are able to refer, right? If that masses are expressed in the grams, molar ratios also you are able to get, right? Unified masses is 26 units or 30 units or 40 units, U symbol we can use. If you write that G symbol beside number 20G, we can read as 20 grams. So in the grams or in the unified masses, you are able to express the mass of the compound. Okay, so understand the ratios here, right? Molecular masses and molar ratios. The next here, it is also gives idea about the evolution of gas or maybe the heat. Suppose if you are observing a gases are evolved. Gases are evolved. So here simply we can equate the masses to their volumes. And you are also able to calculate the volume, unknown quantity, right? At particular temperature and pressure, standard temperature and pressure, STP, right? So this is information. Along with that, also you are able to get such information about their molecules, number of molecules present in the compound before and after the change, right? By knowing Avogadro's number is given as 6.023 into 10 to the power of 23 molecules per mole, right? Mole means simply fixed mass, gram molecular weight, right? So a gram molecular mass substance consists of 6.023 into 20 10 to the power of 23 molecules. It occupies 22.4 liters of volume. So this you need to know, right? Relative masses, relative volumes, relative their molecules, right? So that you are able to give a relation between it. So what the relation you are able to give here? The relation between the mass and mass, the relation between the mass and volume, the relation between volume and volume, the relation between mass, volume, and the number of molecules. These are the relations you are able to give, right? So this is the information we are able to read from the equation. Are you clear about this information? What I'm trying to say? Are you clear? Are there any information required in the interpretation of balanced equation? If you are in confusion, that will be clarified in the following topic. If there is any doubt, please ask me. Otherwise, try to make it clarify in the following example. The relations, right? Mass-mass relationship, mass-volume relationship, volume-volume relationship, and mass and volume number of molecules relationship. That we are trying to understand now. So before understanding these relationships, you need to learn about two laws. That is, one is law of conservation of mass. Law of conservation of mass. Then one more is law of constant proportion. Law of conservation of mass and law of constant proportion. According to law of conservation of mass, no mass difference before the change or after the change. Simple, no difference in their masses. So simply how you can define that, right? Mass neither created nor destroyed. Mass neither created nor destroyed. So according to that, here in the chemical equations, what we can say here, no new elements are produced by the change, but its combination may be changes. So law of conservation of mass, no new atoms are produced. Then law of constant proportion, whatever it may be the quantity provided by you, whatever it may be, you are providing the quantity of reactants. Nothing. There is no importance to the quantities. Always the combination of reactants will be in fixed ratio. Will be in fixed ratio. For example, here hydrogen and oxygen combining and giving you water. So balanced chemical equation is this one. Then here look at 2 parts of hydrogen and 1 part of oxygen. So this is the ratio of reactants. 2:1, right? According to the masses, hydrogen molecular weight, right? This substance, according to the balanced chemical equation, you can calculate 2 into 2 into 1. What 2 into 2 into 1, sir? 2 is coefficient and another 2 is subscript. 1 is atomic weight of the hydrogen atom. Are you clear? What I am written here? 2 into 2 into 1. Did you got meaning for that? 2 is the coefficient and another 2 is it's a subscript, right? Then next, for oxygen, nothing is coefficient, so 1 into 2 is subscript and oxygen atomic weight is 16. So here 2 into 2 into 1 will give you 4. 1 into 2 into 16 will give you 32. So this is the meaning of 2:1. So 4 grams of hydrogen participate with 32 grams of oxygen. Sir, I give you 40 grams of hydrogen, sir. Then 64 grams of oxygen, sir. Can you complete the reaction? Yes, I can complete. But the ratio is always fixed. What ratio? 2:1. 2 parts of hydrogen, that is 4 grams, and 1 part of oxygen, that is 32 grams. So here simply this is I am taken 40 grams, 64 grams. How can we? How can we? So that we can understand by mass-mass relationship, as per law of constant proportion only, that 2:1 ratio simply. Are you getting me? Are you clear? So here, try to understand what actually asking in this question. Look at this question. Here in the example 1, the reaction is given between aluminum and iron oxide and producing the products are given as aluminum trioxide and iron. So here you are asked to find out simply. Suppose that you are asked to calculate the amount of aluminum required to get 1120 kgs of iron by the above reaction. Right? The question is given to find out required amount of iron. That is important thing. The first thing is identifying what you are finding. Right? So I'll go to solve this one. First thing is just you have to verify the given equation is a balanced chemical equation or unbalanced chemical equation. Please help me, anyone. Is it a balanced chemical equation or unbalanced chemical equation?
Unbalanced.
Unbalanced. Very good. Can you make it balanced one? Can you make it this as balanced chemical equation?
Two aluminiums.
Loudly.
2 into aluminium.
Don't say 2 before aluminium. It is not multiplication. Okay. 2 before aluminium. Okay. Written. Next.
2 before iron.
2 before iron. Any other? Now verify. Is it balanced or unbalanced? 2 aluminiums left side, 2 aluminiums right side. Okay. 2 iron atoms, 2 iron atoms. Okay. 3 oxygens, 3 oxygens. Okay. Balanced. Then what to do? Then what to do? Or first step, verification of the given equation completed. After completion of balancing the equation, simple thing, find the atomic weights according to your balanced chemical equation. So 2 into aluminum atomic weight 27 is given in the question. Plus, is there any coefficient before iron oxide? Nothing. So 1 is coefficient, nothing to write before that. Then 2 is subscript of iron. Iron is 56. So 2 into 56. Then add plus 3 oxygens, 3 into 16. I think is clear to you everyone what I am trying here. Why I am written like this. So follow these brackets as it is carefully. Right? So everywhere you can follow these square braces mathematically. Follow them. Compulsory to separate the coefficient. Right? Okay. Next, towards right side. Towards right side. Can anybody write for Al2O3? Tell me. Right side. Al2O3.
2 into 27.
Loudly, please. Just somewhat loud.
2 into 27 plus 3 into
3 into 16.
Very good. 2 into 27 plus 3 into 16. Next one.
2 into 56.
2 into 56. So if it is clear, then remaining are very easy. 2 into 27. It is 54 grams. 2 into 56 plus 3 into 16. 56 twice. 112 plus 48 will give you 160. Then towards right side, 2 into 27, it is 54. 3 into 16, 48. Total 102. 102. Then 2 into 56. It is 112. Then what the sum is? 54 and 160. 214 grams. So here right side also 214 grams. If it is clear, same before and after the change, then your equation is correct. Right? And also you solved in the right way. Correct.
Sir, can we use the number of moles formula?
Later on, not in the same problem. Okay, not in the same problem. In the next one, we'll go for number of moles, finding the volume. Here only the mass is asked. Okay, so here, according to balanced chemical equation, here simply refer your question again. Suppose that you are asked to calculate the amount of aluminum required. So is it a reactant or the product? Required, reactant or product?
Reactant.
So reactant. We can write left side. So I am writing aluminum, left side. Okay. Then go to your question again. Required to get. Is it a product or reactant?
Product.
Getting what?
Iron.
Iron. So towards product side I can write. So this is my relation. Between whom? Aluminum to the iron. That's it. Completed. If you identify the relation, very easy. Your problem half done. More than half, not half. Then, according to your balanced equation, what amount of aluminum participated in the reaction? Can anybody? What amount of aluminum participated in the reaction? Don't follow your textbooks, just follow the screen.
54 grams.
54 grams.
54 grams. It is 54 grams. You can drop down. Then next, what amount of iron is produced by 54 grams of aluminium?
112 grams.
It is 112 grams. Drop down. Then next, according to your question, what amount is required? Aluminium required. So unknown quantity that I am taking as X to get 1120 kgs of iron. That's it. So I made a relation. Then what to do after completion of this relation? Next thing is just using the law of constant proportion. That is, cross products are equal. Law of constant proportion, the ratios are same. What is law of constant proportion? Ratios before the change, after the change, they are same. Okay, then that we are using as cross products are equal. Suppose here two ratios are equal between A by B is equal to C by D. So this expression also we can write as A into D is equals to B into C. Is it or not? The ratio also can be expressed as cross products are equal. So that we are using here. So simply we are going for cross products. So X into 112 is equal to 54 into 1120 kgs according to their units written there here. Then next, copying the same and transposing here. 112 moving on right side becomes denominator here. Okay, then next cancellation. So you can make it cancel using the suitable table. Here grams cancel. The next cancellation here, simply I can cancel 112 and 1120, 10 times cancel, and kg remained ice. Kg remained ice here, ice is. So what is remained here? X is equals to simply 54 into 10 kgs is equal to 540 kgs. So what amount of iron is produced here? X is what? Sorry, aluminium is required. X is aluminium required. See your relation. X is taken for aluminium here. So simply I can write here that to get 1120 kgs of iron, 540 kgs of aluminium is required. So this is the problem. Are you clear about this one? Everyone, are you clear about this one? Sure. So we have two more problems here. They are very, very important. Join immediately using the same link. We'll start in the next meeting. Join immediately.